Welcome to your adding and subtracting fractions tutorial with different denominators. So we're going to look at some key vocab just to start. Equivalent fractions, so we can use pictorials here. We've got our fraction wall here. An equivalent fraction is with two fractions with different denominators, but they have the same value. So I can see here 1/6 is the same equal part as 2/12. So a fraction is an equal part of a whole. I can see it here on my wall. 1/6 is the same as 2/12. They are equivalent fractions. So sometimes we will need to convert fractions. We will need to simplify. We need to remember numerator is our top number. Denominator is our bottom number. So this number here is the numerator. This number here is the denominator. When adding and subtracting fractions with different denominators, we need to convert one fraction to have the same denominator, to have an equivalent fraction with the same denominator. So I can see here, I want to add my 2/12 to my 1/12, but they have different denominators. Their bottom number is different. So to find out the answer to this calculation, I need to convert my 1/6 to my 12th. So I can do that with a fraction wall. I can see it here with my pictures. I can see that 2/6 there is 4/12. They are equivalent and they now have the same denominator. Or I can use the method of multiplication. So I know 6 goes into 12 twice. I'm timesing by 2. That's our method. So whatever you do to the bottom number, you must do to the top number to make sure you're getting that equivalent fraction. So 6 times 2 is 12. 2 times 2 is 4. And that's our method. Whatever we do to the bottom number to get an equivalent fraction, we must do to the top number to make sure they're equivalent. So children sometimes forget to do both numbers, but we must do both numbers. So to help children, sometimes it is useful to have a fraction wall in front of them, and they can also do pictorial representations, which I can show you now. Starting here, so we've got some questions. So 1/2 plus 7/10. Well, I can see here that first of all, the denominators do not match. So that first thing I need to do is to make sure the denominators match. 2 goes into 10 equally. So I know I can use my knowledge of multiplication to make this an equivalent fraction using tenths. So I know 2 goes into 10 5 times. So I'm timesing by 5. What number I must do to the top number. So that now becomes 5/10. And interestingly with a half, so your denominator here, your numerator will always be half that in half. That's how I can check that I'm right. So now I've got 5/10. 1, 2, 3, 4, 5 plus 7/10. 1, 2, 3, 4, 5, 6, 7. And I can see with my bar model, my answer is going to be 1 whole and 2 parts. Yep, 1 whole and 2/10. So I could have just added across the numerators, though. I could have done 7 plus 5, and that would have got me 12 over 10. But the numerator is bigger than the denominator, so I know I need to convert to a mixed number fraction. So my 10 is my whole. I can see here my 10 is my whole. So I've got 1 whole. So I remove that 10, and then I'm remainder. Here, there's 2/10 remaining. So that is my mixed number fraction when it includes a whole. Let's do another one. Well, that's the same, that half. So, and we're using 10 again. So it's easier to look for this bigger fractional number at the bottom of our denominator here. 2 goes into 10 and 5 goes into 10. So I'm going to make this my common denominator. But now I need to convert both numbers to have this common denominator of 10. So I'm going to put 10 here, and I'm going to put 10 here. Well, I know a half of 10 is 5. So I know that's going to be 5/10. I'm then going to do the same here. So 5 times 2 is 10. Whatever I do to the bottom number, I must do to the top number. So I'm going to times that by 2. 1 times 2 is 2. And now I'm just going to make sure I cross those out so I know not to use them. I'm going to add across 5, 6, 7, 8, 9, 10. I've got 10 on my numerator, 10 as my denominator. Those two values match, so it's 1. Children might also want to use a bar model to help them. 1, 2, 3, 4, 5. 1 and 2, and 1, 2, 3. I can see my whole has been shaded because my whole is worth 10 equal parts. Let's do one more down here. 6 goes into 12 and 3 goes into 12. So I'm going to make 12 my common denominator. I'm going to get my calculation ready. So my two sums I'm going to change. 3, 6, 9, 12. I'm timesing by 4. Whatever I do to the bottom number, I must do to the top number. 4 times 2 is 8. Same with this one. 6 goes into this one, sorry. 6 goes into 12 twice. So I'm timesing by 2. So that's 12. And then 5 times 2 is 10. And now 1, 2, 3, 4, 5, 6, 7, 8. Done my 8 twelfths. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I've done my 10 twelfths. And then I'm adding one more 12. And I can see I've got one whole. 1, 2, 3, 4, 5, 6, 7 parts. My mixed number fraction, we always have to make sure we go from our improper fraction, when the bigger number's on the numerator, to a mixed number fraction like this. Children might not need a bar model and they can just count across. So 8 plus 10 is 18, plus 1 is 19. And if they do count across, they need to make sure that they are and we'll do one more up here. So 5 goes into 20, 5, 10, 15, 20, 4 times. So I'm timesing by 4. So I know my denominator can now be 20. Whatever I do to the bottom number, I must do to the top number. 4, 8, 12, 16. And I can just add those across. 16 plus 7 is 23 over 20. And I can see that is a improper fraction. 20 is my whole. So I've got one whole and 3 20ths. And that's how we add. I'll now look at a few subtractions. It's the same method. So we always convert our denominator and then we do our calculation. So here, 2 goes into 6 3 times. So I'm timesing by 3. So now this this fraction becomes 6 as my denominator, 3 as my numerator. Like I said before, with a half, your numerator will always be half your denominator. And now I can subtract 5 from 3. So I'm doing 5, 6 now, take away 3, 6. That's going to be 2, 6. Children can also do this in a bar model. 1, 2, 3, 4, 5 here. They've got this one, they're taking off 3. 1, 2, 3. And they can see they have their 2, 6 remaining. I can also see that this can be simplified. So 2, 6 can be simplified to 1/3. That's in its simplest form. We'll do a couple more. This one here. 4 goes into 8 twice. So I'm timesing by 2. So I'm going to do 7 8ths, take away. And whatever I do to my bottom number, so I've times by 2 to my denominator, I do to my top. So I'm going to do 3 times 2 is 6. And I can now see, if I take away my numerators, I've got 1/8. We'll do one more. 8 here is my denominator. And 3 is my numerator. So 2 goes into 8, 2, 4, 6, 8, 4 times. So it's absolutely fine for children to do their multiplication on their fingers. And if they need to, they can have a multiplication chart next to them because we're looking at fractions and not multiplication knowledge. So I'm going to do what if I do to the bottom? I must do the top. So that number becomes 4 8ths. So 4 8ths take away 3 8ths is 1/8. I can check that here. So I've got my 1, 2, 3, 4 eighths, take away an eighth, I'm left with 3 eighths, 1 eighth. 1, 2, 3, there we go, left with my 1 eighth. So when we're using our fraction knowledge, adding and subtracting fractions, quite often children will come across real world problems. So this one here, Jack walks to school and it's 7/9 of a kilometre. Aisha walks 2/3 of a kilometre. How much further does Jack walk to Aisha? Well, I know that the denominators do not match. So the first thing I'm going to do is make them match. So I'm going to keep my 9 and I'm going to change the one with the thirds. So 3, 6, 9, I can times this by 3. So 3, 6, 9 on the bottom, 2, 4, 6 on the top. I can now take those away and I can quite easily see 7 take away 6, 1/9. Jack walks 1/9 further than Aisha. So remember, when we're looking at fractions, we need to use our knowledge of equivalent fractions. We need to always make sure the denominators match. And there you go.